Hello everyone. So today we'll discuss the concepts of basics of climatology. Now, what is weather and what is climate, right? Now, weather is the day-to-day state of atmosphere in a region, right? Remember, it is day-to-day state, right? And climate is a statistical weather information, that is, it is the average of weather conditions over a period of time, right? Although sometimes these terms are used interchangeably, but they differ in terms of length of time they measure, right? So let's discuss the difference between climate and weather. Now, as I told you, climate describes the average condition at a specific place at a given time, right? So it includes five major components: atmosphere, hydrosphere, cryosphere, land surface, and biosphere. Now, on the contrary, weather, it describes the atmospheric condition at a specific place at a specific point in time, right? So it may be day to day temperature and pressure conditions. Okay, so climate, then it includes precipitation, temperature, humidity, sunshine, etc. over a long period of time. And on the contrary, weather includes sunshine, rain, cloud cover, winds, etc. over over a short period of time, right? Now, climate, the study of climate is known as climatology. The study of weather is known as meteorology, right? Now, it is aggregate weather statistics over 30 years period, and this is real time measurement that we've already done, measured over long period and measured over short term. Okay, now what are the factors affecting the climate? Distance from the sea, ocean currents, direction of prevailing winds, distance from the equator, shape of land, El Nino phenomena, and these are the natural factors. Now, apart from the natural factors, there are anthropogenic factors also that affect the climate. Okay, so let's discuss each in detail. Now, the first one is distance from the sea, that is continentality. Now, remember one thing, the sea significantly affects the climate of a place. It has a moderating influence on the climate of coastal areas. You can see here the climate of coastal area. Here it is warm summers and cool winters. Remember, it is warm and cool. In the interior part, it is hot summers and colder. So it is hot and colder. So the range of temperature in the interior parts is high. The range of temperature in the coastal area is low, right? Why? Because the sea has a moderating influence on the coastal areas. Similarly, the temperature in Mumbai region will be significantly different from, or the climate in Mumbai will be different from climate in Delhi. Why? Because Mumbai has this, the Arabian Sea has a moderating influence on the climate of Mumbai, right? So the temperature range in Delhi will be more than Mumbai. Next, coming on to the direction of prevailing winds. Now, winds direction, they have a significant influence on the climate, right? How they affect the climate? Now, you can see it here. The winds which are onshore, you can see the blue ones, those are the westerlies. So the westerlies, they are onshore, that is, they carry the moisture from the North Atlantic Ocean and they cause rainfall in the Western European countries, right? On the contrary, the winds over the Sahara are offshore, that is, they move from the land to the sea. So they do not have moisture, right? So that is why this is this whole desert. So these winds, they significantly affect the climate of that place, right? Similarly, in case of India, the southwest monsoon winds causing monsoon or water rainfall in the summer season, right, in the month of June to September. And in case of winter, there is northeast monsoon in the southern Andhra Pradesh and Tamil Nadu. So these are also the influence of prevailing winds over that region. Now, coming on to the ocean current, the next factor which influence the climate change. Now, ocean currents we've already discussed in one lesson. Now, how these affect the climate? There are two types of ocean current. One is warm. The red ones are shown in warm, right? And then there is cold. The blue ones are shown in cold current. The blue ones are cold, and the red ones are warm current. Now, warm current has a warming effect on the areas in which they flow, right? This Gulf Stream, the North Atlantic Drift, Kuroshio current, these all the red ones, they have this warming effect, right? That is why, as I told you in the ocean current class, that the ports in the Norway region, they are ice free. Why? Because of this North Atlantic warm current, right? And on the other hand, the cold current, how it affects the climate. Now, cold currents, they have a desiccating effect on the nearby areas. That is why in this Peru region, or in this region of Africa, we have Namib Desert. Here we have Atacama Desert. Here we have Mojave Desert. In the West Australian, due to the West Australian cold current, we have this whole western part of Australia is desert. So how these cold currents are significantly affecting the climate of that area. Okay. Now, the shape of the land or relief. Now, relief also significantly affects the climate. How it affects the climate? You can see it here. As we move up the mountain, the temperature gradually decreases. Now, why the temperature gradually decreases? This is because as we move, as the altitude increases, the air becomes thinner and it is less able to absorb and retain heat. That is why the temperature is gradually decreasing as we move up the mountain. Okay. Now coming on to the distance from equator. Now distance from the equator, it again affects the climate of place. This is because in the tropical region here the rays of the sun are directly overhead, right? And that is why the intensity of sunlight here is high, right? On the contrary, there are slanting rays in the temperate region and the polar regions. That is why the intensity of sunlight is low. This is the reason that tropical regions have different climate and temperate regions and polar regions have different climate, right? Temperate regions are cooler, polar regions are frigid, and tropical regions are warmer. Okay. Now coming on to the El Nino concept. Now El Nino, this we've already done in one of the lessons. So it significantly affects the climate of that area. How it affects? See, in this case, this one is Australia and this is South America. So in normal conditions, as I told you earlier also, in the normal conditions in Australia, there is on the eastern part there is significant rainfall, and on the western part of South America there is Atacama desert. There are drought like conditions. Okay. But in the El Nino condition the things get reversed. There is drought in the eastern part of Australia and there's rainfall in the western part of South America. So this is because of the El Nino conditions. Okay. Now coming on to the anthropogenic factors. Now after this industrial revolution, there is this whole industrialization and urbanization taking place. Now due to this, the forest cover has been significantly reduced. Now since the forest cover has reduced, so it has led to the increase in the amount of carbon dioxide. Now this increase in the amount of carbon dioxide as well as the other greenhouse gases, that has led to the concept of global warming. Now this global warming is leading to mean sea level rise, right? And this global mean sea level rise, it is expected that it may reach to 2 meter, like it may increase by 2 meter by the end of this century, right? And this 2 meter increase may lead to catastrophic consequences, especially on the coastal areas. Okay. So these are the natural as well as anthropogenic factors that affect the climate. Okay. Thank you. Hello everyone. So today we will discuss the concept of pressure belts. Now I am Bhumika Saini. I have done my engineering from MNIT Jaipur and currently preparing for civil services. You can follow me on Unacademy by following this link, and you can also voluntarily contribute to Unacademy by following this link. Now in this lecture today we will be discussing what is pressure gradient, what are the different pressure belts of earth, and what is the vertical and horizontal distribution of pressure and the factors influencing it, right? So first of all, let's discuss pressure. Now what is pressure? A column of air, it exerts weight at any given place at any given time. Now that weight which a column of air is exerting, that is known as pressure. So we can see it here, the weight of column of air at a given place and at a given time is called air pressure or atmospheric pressure. Now the instrument used to measure pressure is known as barometer, and atmospheric pressure is measured as force per unit area, right? And the unit used to measure this is known as millibar, right? And 1 millibar, it is equal to force of nearly 1 gram per square centimeter. As we have seen it here, force per unit area is the way how we measure pressure. Okay, now after discussing pressure, let's discuss what is pressure gradient. This concept we'll be using for understanding the different pressure belts of world, right? So as we have discussed pressure, now the rate of change of pressure between any 2 points on Earth's surface is known as pressure gradient. One area may have high pressure, the other area may have low pressure, right? So the difference or the rate of change of atmospheric pressure between these 2 points will be known as pressure gradient, right? And this is indicated by spacing of isobars. You can see it here. This L represents low pressure, this H represents high pressure, right? In case of low pressure, the isobars are closely spaced. Can you see it here? In case of high pressure, the isobars are widely spaced, right? So closing space of isobars indicate a strong pressure gradient, while wide space suggests a weak gradient. Okay, now let's discuss the vertical and the horizontal distribution of pressure. Okay, so the columnar distribution of atmospheric pressure is known as vertical distribution. See, if we go up the mountain, what happens? The pressure of air reduces, right? And as we come down the mountain, the pressure of air increases. Why this is so? Because as we've studied that what is pressure? Pressure is weight of air column exerted at any given place, right? Now what happens? The mass of air above in the column of air, it compresses the air under it, right? Hence the lower layers, that is the low altitude region, will have more dense layers than the upper layers, right? And as a result, the lower layers of atmosphere, they have higher density and they have high pressure, right? On the contrary, the higher layers are less compressed, that is why they have low density and low pressure. So as we move up the mountain, we have low pressure, the pressure gradually reduces, and as we move down the mountain, the pressure increases. You can see it here, the altitude with altitude versus pressure graph. As the altitude, this in the x, on the x-axis we have altitude, on the y-axis we have pressure. So as the altitude is increasing, the pressure is gradually decreasing, right? So this is as such inversely related. Now coming on to the horizontal distribution of pressure. Now the factors responsible for variation in the horizontal distribution of pressure are: one is air temperature, the other one is Earth's rotation, the third one is presence of water vapor. Now we'll discuss each in detail. So the first one is air temperature. Now in this, Earth, as we know, Earth is not uniformly heated. Why? Because there is unequal distribution of insolation. You can see it here. In this equatorial region, there is direct rays of sun, right? So the intensity of sunlight is more here, right? And on the contrary, in the polar regions, what happens? The oblique rays of sun fall, right? And in case of equatorial, the direct rays of sun falls. So what happens? In this region, the temperature is very high. Since the temperature is high, the warm air rises, right? You can see it here, the red one, that is the warm air rises, and at the surface there is low pressure. Now on the contrary, what happens on the polar region? The cold air being denser, it sinks, right? Here the warm air being lighter, it rises. Here the cold air being denser, it sinks, right? And I told you what is pressure? The weight of column, the weight of air column exerted at any given place. So since the air is descending here, that is why high pressure, and since the air is rising here, that is why low pressure. So this air temperature is definitely affecting the horizontal distribution of pressure. Okay, the next one is the Earth's rotation. Now the Earth's rotation, it generates centrifugal force, right? So the low pressure belts of subpolar regions and the high pressure belt of subtropical regions, these are created as a result of rotation. Now you can see it here. I told you this is the equatorial low pressure belt generated due to the direct rays of sun, right, and intense heating. This is the polar high pressure region. Why? Because the cold air, it sinks, and that is why high pressure here. Now these two pressure belts, that is the subtropical high pressure belt, this one that is horse latitude, that is the subtropical high pressure belt, and this one that is subpolar low pressure belt, these are generated due to dynamic factors. The main reason is Earth rotation, right? We'll discuss them in detail. The next one is pressure of water, presence of water vapor. Now this is inversely related. Air with higher quantity of water vapor, it will have low pressure, and that with low quantity of water vapor will have high pressure. So now let's discuss each world pressure belt in detail, right? On the Earth's surface, there are total 7 pressure belts. You can see it here. This one is the equatorial low pressure belt, right? This is one pressure belt. Then two pressure belt each in one hemisphere, that is subtropical high pressure belt in northern hemisphere and the one in southern hemisphere. Then subpolar low pressure belt, again two in each hemisphere, right? Subpolar low pressure belt in northern and southern hemisphere. Then coming on to the high pressure, that is in the north pole, and then again in the south pole. So total there are 7 pressure belts. Okay, so the first one, that is equatorial low pressure belt. Now I told you that this pressure belt is generated due to thermal reasons. Why? Because of the vertical rays of sun here, there is intense heating, right? And that is why the air expands, it rises, and that leads to low pressure to develop here. You can see it here, the warm air will rise, it will expand, right? And that is why at the surface low pressure. Now this warm air, when it expands, it reaches the troposphere, it descends at 30 to 35 degree latitude, that is the subtropical high pressure belt. Now, since the winds are descending at this high pressure belt, that is why there is high pressure in this region. Similarly, in this southern hemisphere, winds from equator, it rises, it descends at 30-35 degree north as well as 30-35 degree south. Okay, so coming on to the next one, that is subtropical high pressure belt, right? So I told you that 30-degree north and south of equator lies the area where the ascending equatorial air current descends. Okay, and thus this area is thus an area of high pressure. Why? Because the winds here are descending. It is also known as horse latitude. You can see it here. This one is known as doldrum because it is a calm zone. This subtropical high pressure belt is known as horse latitude. Okay, now coming on to the this subpolar or circumpolar low pressure belt, right? Now these are located between 60 to 70 degree in each hemisphere, right? Now what happens in this region? This zone is marked by ascent of warm subtropical air over cold polar air blowing from poles, right? Now see, I told you the two pressure belts, the subtropical high pressure belt and subpolar low, these are mainly due to the dynamic reason, that is earth rotation. Here the winds were descending. Now in this region what happens? The warm subtropical air, right, it moves towards it meets with the cold polar airs from the poles, right, and the warm air rises here. Due to earth's rotation, here the low pressure is created. This zone is marked by ascent of warm subtropical air over cold polar air blowing from poles. Due to Earth's rotation, the wind surrounding the polar region blows towards the equator, right? And centrifugal force operating in this region, it creates the low pressure belt. Okay, and this region is also marked by violent storms in winter. So the next one is the polar high pressure areas. As we have already done, that this pressure belt is again thermally induced. Why? Because the sun rays are oblique here, and at the north and south poles between 70 to 90 degree north and south, the temperatures are extremely low, so the winds will be cold. Cold air is denser, so it sinks, right? So the cold descending air gives rise to high pressure over the poles, right? And these are also known as polar high. These regions are characterized by permanent ice caps. Okay, thank you. Hello everyone. So today we'll discuss the concept of cloud formation and its types. I am Bhumika Saini. I've done my engineering from MNIT Jaipur. I've appeared in CSE interview twice, and you can follow me on Unacademy by following this link. So, what are clouds? Now, clouds are floating water particles which are condensed, and these are attached to tiny particles like dust and salt particles, right? But before understanding the concept of clouds, you need to understand three terms. One is evaporation, the second is condensation, and the third one is precipitation, right? Now, what is evaporation? Evaporation means when the state of water it gets changed from liquid to gases, right? So first of all, evaporation takes place. So here the water, it is evaporated in the form of water vapor, right? Now when this water vapor it rises, it cools and expand, right? And if it reaches a level beyond the level of condensation, so this water vapor gets converted into water particles, right? Now these tiny droplets of water, they condense along the hygroscopic nuclei. Hygroscopic nuclei are generally the dust and salt particles. Now it is along these nuclei that these droplets, tiny droplets of water are attached, and this floating condensed water vapor is known as clouds, right? And when the cloud cannot carry any further moisture, it is at that point that this precipitation occur. So evaporation first, then condensation and precipitation. So you can see it here. Clouds form when the invisible water vapor in the air condenses into visible water droplets or ice crystals. Right? There is water around us all the time in the form of tiny gas particles, that is water vapor, that is after the process of evaporation. Right? And there are also floating particles around in the air, such as salt and dust. These are known as aerosols. So it is along these hygroscopic nuclei that the water vapor condenses in the form of tiny water particles, right? And this water vapor and aerosols, these are constantly bumping into each other, right? And when the air is cooled, some of the water vapor sticks to the aerosols, which then collide. This is known as condensation. So that's what I told you. So first evaporation, then condensation, and then precipitation. Okay, and condensation along these hygroscopic nuclei, that is aerosols. Okay, and eventually what happens, bigger water droplets form around the aerosol particles, and these water droplets start sticking together with other droplets and they eventually form clouds. Okay, so now, but this cloud formation, see, clouds they form when the air is saturated, right? And it cannot hold any more water vapor. Now, this will happen in two ways. Either the amount of water in the air has increased, or the air is cooled to its dew point. Now, let's see how this happens. The amount of water in the air increase, for example, through evaporation, right? Now, if the amount increases to the point that the air cannot hold any more water, right? So one case is this, and the second is if the air is cooled to its dew point. Now dew point is the point where condensation occurs, right? And the air is unable to hold any more water. You can see it here. So either the water the amount of water vapor is amount of water is increased through the process of water vapor, or the air, this whole particle, this whole gases, like this whole air is cooled to its dew point. One is evaporation, then this whole air is cooled to its dew point. So these are the two things when these clouds are formed. Now, what causes clouds to form? Either surface heating, orographic barrier, fronts, convergence, turbulence. Right? Now, let's discuss each in detail. First is surface heating. Right? These are the five factors which lead to air rising and cooling, and then the clouds form. So, first is surface heating. This happens when the ground is heated by the sun, which heats the air in contact. So, that is actually the process of evaporation is taking place. Right? And in this case, cumulus clouds are formed. Now we'll discuss all these clouds, the different types of clouds in the next few slides. But first thing is, if there is surface heating, then cloud formation will take place. Why? Because the air is rising, and if it is cooled beyond the level of condensation, then clouds will form. Okay, and the other factor is topography or orographic barrier. Now, if the shape and the features of the area, they can also cause clouds to be formed. Now, suppose if there are mountains or hill, right? So the wind is forced to ascend. You can see it here. If there are, this is the mountain, right? And if the wind is forced to ascend, then also it will cool beyond the level of condensation and clouds will be formed. Okay. So the orographic barrier or orographic forcing is another reason for cloud formation. The third is fronts. Now, fronts we'll discuss in another lesson. But what are fronts? These fronts are generated when two contrasting air mass they meet or converge, right? Now at that place also clouds are formed when a mass of warm air rise up over a mass of cold dense air. Now these are two contrasting air mass, one is warm and the other one is cold and dense, right? So at that place where fronts are formed, there also clouds are formed. Okay, then convergence. Now if there is convergence of air flowing from different directions, right, and if these are forced to rise, right, then also these can cause cumulus clouds and it may cause drizzle. The fifth factor is turbulence. Now, if there is a sudden change in wind speed with height, right, it creates turbulent eddies in air. Now, this happens when there is a when there are tropical cyclone conditions, right? And these are the different factors which may lead to different types, the different shapes, different size, and textures of cloud, right? So, we'll discuss the different types of cloud. Now, the different names of clouds. First, let's understand this. There are stratus clouds, cumulus clouds, cirrus clouds, alto clouds, and nimbo clouds. Now, what does stratus mean? Stratus means layered, a flat layered cloud. You can see it here. These are stratus clouds, right? The next is cumulus clouds. Now, cumulus clouds are this heaped up clouds, and they appear like a cauliflower. You can see it here. These are the cumulus clouds. Then comes the cirrus cloud. Now these are high clouds. These are high altitude clouds and these are fibrous or wispy in nature. You can see it here. These are the cirrus clouds, right? The next one is nimbus clouds. Now nimbus means rain bearing cloud. You can see it here. These are the dark clouds which will always bring rain or drizzle. Okay. The next one is alto clouds. Now these are clouds at medium level. That is, their height ranges from between 7,000 to 20,000 feet. Now we'll discuss all these clouds, the different types of cloud in the next lesson. Thank you.